The moment curvature analysis tool is used for the analysis and design of beam and column elements near their moment capacity. This tool assists determine moment capacity for design purposes and compute plastic hinge properties for nonlinear pushover analysis. The C-Suite moment curvature analysis tool is fully integrated with LARSA 4D's section composer, allowing you to define custom sections, including composite sections and sections with holes. Here we have a confined column section in Section Composer. To access the Moment Curvature Analysis tool, navigate to Analysis, C-Suite, Moment Curvature Analysis. This is the main window of the application. The column section is selected automatically, but we can manually select another section or add multiple sections into the rows to analyze them all at once. We can also open the Moment Curvature Analysis tool in LARSA 4D via Design, C-Suite, Moment Curvature Analysis. In this case, we must enter the member ID, and the parametric section assigned to the member will be selected automatically. Click Edit Material to modify or create nonlinear material models. The tool includes predefined nonlinear material models for concrete, steel, and tendons, such as unconfined and confined concrete models, for example, Mander, Hoshikuma. Normal strength and high strength concrete models, for example, Popovich, Hoshikuma. Pre-stressed and non-pre-stressed steel models, and material models from design codes. Additionally, users can define custom material models by manually entering the stress-strain relationship. Click Edit Rebar to define reinforcement. If rebars were previously defined in Section Composer, they will appear automatically. We can also define tendons. The pre-stress force applied to the tendons will be incorporated into the sectional analysis accordingly. Here we can select the direction of the moment. The options are the section Y direction, section Z direction, or both. To create a moment curvature curve for a single axial force, we shall enter the value in the start of axial force range field and leave the others empty. To analyze a range of axial forces, we shall enter values for start of axial force range, axial force increment, and end of axial force range. The tool will perform a separate moment curvature analysis for each axial force in the range. We can either click Analyze All to analyze all sections listed in the spreadsheet, or click Analyze under Analyze and View Results to run a moment curvature analysis for a single section. After the analysis, the moment curvature results window appear. Here we can see both the moment curvature curve and its equivalent bilinear curve. We can select the options to show only the positive bending, negative bending, or the full graph. To the top left, we have controls to switch between moment directions and the axial force values. Beneath that, we can see the data points of both the analytical moment curvature curve and its equivalent bilinear moment curvature curve. By default, the moments are taken about the element local coordinate system. Using the drop-down menu on top of the curve grid, we can switch the moment reference to the geometric centroid of the section. Click Show Analysis Report to generate a detailed moment curvature analysis report. The section information is presented at the beginning of the report. Analytical moment curvature curves and their equivalent bilinear curves for each selected moment direction within the specified axial force range are given. By clicking Details under a moment curvature diagram, we can see a detailed breakdown of the curve, the maximum compressive strain in the section, given in millistrain, the neutral axis location of the section, the internal compression and tension forces, moment at the section, and the curvature values are tabulated. Material Events column highlights critical material events such as cracking, crushing of concrete, yielding and rupture of steel. The strain diagram and internal force distribution of the section at critical event points are also presented below. You can also click View Detailed Results to open the Detailed Moment Curvature Results window. You can click on any point on the interactive moment curvature diagram to see the strain, stress, and resultant forces of the section shapes, rebars, and the material at the corresponding moment curvature point. Important material and rebar events are also marked in the moment curvature curve. You can click on them to observe the events reported under Shape Material Events or Rebar Material Events. Click the arrow on the right for additional options. Below, you can switch between the moment curvature directions and change the units. There are options to filter the results at the top. You can hide any shape within the section and see the resultant forces accordingly. You can hide specific rebars as needed. You can adjust the moment curvature curve to show only the concrete events or the rebar events. To model material nonlinearity in pushover analysis using analytical hinge elements, open the Moment Curvature tool in LARSA, check the option Export Curves to Section for Inelastic Elements, and click Analyze. The generated curves will be saved in Spring Properties spreadsheet. We can view these curves by right-clicking on a row and selecting Edit Curve. These curves are automatically assigned to the selected section for use in pushover analysis. Be sure to visit our website to review C-Suite's additional product capabilities, supporting biaxial interaction analysis in pier, column, and girder code check.